We did some review yesterday over these sections. I want to do it again today. So the first one, I have a graph here, and I want you guys to take a minute and try this question. Continuous. Okay, then you have to tell me why using our rules. So, remember the rules, the limit has to exist, the function has to exist, and they have to equal the same number. So at -1, what would be our reason? Okay, you could say the limit does not exist because the left and right don't match. Could you also say the function doesn't exist? Yeah, so this one breaks multiple rules. At 0, does the function exist? Yes. Does the limit exist? Yes, left and right go to the same point. But do they equal? No. So the limit is not equal to the function. Okay, at 2, does the function exist? Yes. Does the limit exist? No, because the left and right don't match up. Okay, at 4, does the limit exist? Does the function exist? No, because it's an open circle. Did we do okay on those? Alright, B, the limit as x approaches infinity. So as x is going to positive infinity, where is the y value going? Negative infinity. As x goes to negative infinity, if I continue on my graph this way, what's it look like it's approaching? 1. Okay, as you approach 2 from the left, so you're coming in smaller than 2, what y value? 1. As you approach 0 overall, so both the left and the right, what y value are we going to? Are we doing okay with reading those graphs? Next thing, if I want to talk about discontinuities. In a fraction, what are we worried about? Okay, so I'm just going to factor it first. If I simplify this, what's the denominator factor into? Okay, those cancel. Give us 1 over x plus 1. So this is discontinuous. Even though it canceled, that's still a place where it's discontinuous. When x is 3 and when x is -1. Because the 3 canceled, we know that makes a hole on the graph. So what kind of discontinuity is it? -1 did not cancel, so that means it's an asymptote. So what type is that? Okay. B. On a piecewise, all we really need to check is if these pieces match up. If they do, then there's no discontinuity. If they don't, we have one. So -1, if I put it in the first one, we get out 0. If I put -1 into the second, we get -1 plus 3, which is 2. So they don't match. So it's discontinuous when x is -1. What type would that be? Jump. You are jumping from one piece of the graph to the next. So we have our rules of continuity, and then we have our types of discontinuities that we need to know. Then we got into calculating these infinite limits. In a fraction, what was our strategy? 1 over the highest degree or highest power of x. So that would be 1 over x to the 4th. So that would give me a 3 minus 5 over x squared plus 6 over x to the 4th. On the bottom, we get 4 over x to the 4th minus 7. We know whether it's going to positive or negative infinity, a number divided by infinity always turns into 0. So we get negative 3/6. On B, we can't divide by the highest power of x because we don't have a fraction. I can't just plug in because it's infinity minus infinity. If it were infinity plus infinity, I could say that's just infinity. So what do we do? X minus x plus 2 plus x on top of that. Okay, when you multiply those radicals, they drop. Conjugate, outside and inside cancel. Minus x times x is x squared over my denominator. Now what happens?
X squared.
X squared is negative x plus 2 over x squared. X squared minus x plus 2 plus x. Now it's a fraction, so now what's our strategy? I'm taking times 1 over x. I know for the radical purposes, 1 over x is the same thing as the square root of 1 over x squared. So to take it in the radical would be an x squared. So I get negative 1 plus 2 over x over, so if I take my x squared under that radical, 1 minus 1 over x plus 2 over x squared. Plus, this x was outside the radical, so I take it times 1 over x, which I just get 1. So a number over infinity always goes to 0. And we get negative 1/2. So that was our most recent section. Any questions on that? The only other thing, we didn't get to one of these yesterday either, was our epsilon delta. So proving our limit. Remember, it was helpful to write the goal on these. And it's always if the distance between x and the number it's approaching, so the absolute value of x minus 3, is less than delta, then the distance between your function and the limit, so 2x minus 5 minus 1, is less than epsilon. That is the definition of a limit. That's what I am trying to prove. To prove it, the very first thing we did was found our formula for delta. And we got it by using this epsilon expression. So that's the absolute value of 2x minus 6. What would you do now?
Take it to
Okay, so if we divide it, the absolute value of x minus 3 is less than epsilon over 2. That's what we needed because these match. I have the absolute value of x minus 3 in both places. So the second step is the proof. You have to first tell me what epsilon is, or sorry, what delta is. So you're going to say delta is epsilon over 2. And then we restate the first half 2/3 of this, everything except the less than epsilon. So if the absolute value of x minus 3 is less than delta, then the absolute value of 2x minus 5 minus 1. And now I have to work it out until I get my less than and my epsilon. So I know that's the absolute value of 2x minus 6, or 2 times the absolute value of x minus 3. But I already know the absolute value of x minus 3 is less than delta, so 2 times that would have to be less than 2 delta. So I got my less than in here. And then we know delta is equal to what? So 2 times epsilon over 2 is epsilon. So we got the less than and the epsilon. And that was our final proof. Do you guys have any questions? Then I have a handout for you.